All right, one of the things that we need to know how to do is to use concentration as a conversion factor. Concentration, remember, is a relationship between the amount of solute over the amount of solution. And so any relationship can be used as a conversion factor. The mass percent concentration is a relationship between grams of solute and 100 grams of solution. So what this means is if you have a 14.5 mass percent glucose solution, then that means that there are 14.5 grams of glucose in every 100 grams of solution. So you can write the concentration as a relationship this way and use it as a conversion factor. The two conversion factors that are possible are these two over here, with the solute on top or with the solute on the bottom. So these are the two possible conversion factors that you can have given this relationship. Remember, any relationship can be written two ways as a conversion factor. So this particular question, how many grams of glucose are in 350 grams of this solution, this 14.5% glucose solution? So what we know is the amount of solution, and what we want to know is the amount of solute. So we are converting 350 grams of solution into grams of the solute, glucose. To do that, we're going to want the amount of solution on the bottom and the amount of solute on the top. So we're using this one over here, this one that was over here. And so what we get here is 50.8 grams of glucose. And that makes sense. We can make a prediction before we start. If you have 350 grams of solution, then the amount of glucose in there is going to be less than 350 grams. So let's try making a prediction for this next one before we calculate it. So this time we know the grams of glucose and we want to know the grams of solution. So we're doing a conversion from solute to solution. So if we want to have 75 grams of glucose, then let's make a little prediction here. We're going to need more than 75 grams of solution because the solution has a lot of water. Only 14.5% of the solution is glucose. So we're going to need way more than 75 grams of solution. So that's our prediction. We'll see if we use the right conversion factor and get that answer. We want to stop talking about glucose and start talking about the solution. So we need this one here. And that gives 517 grams of solution, which is more than 75. So that gives us some confidence in our answer. Here's some conversions with molarity instead of mass percent concentration. Molarity, the amount is moles of solute per liter of solution. So remember, it's always amount of solute over amount of solution. In the mass percent, it was grams of solute over 100 grams of solution. For molarity, it's moles per liter. Okay, so I have written the molarity as a relationship here. 2.35 moles of hydrochloric acid being equal to 1 liter of the hydrochloric acid solution. So that's the relationship that's expressed by that molarity. That relationship can be written as either of these two conversion factors. Okay, this time we know the amount of solute that we want. We want 1.86 moles of hydrochloric acid. So the conversion factor we need is the second one over here. And the amount that we come out with is 0.791 liters of solution. And that makes sense because if we had a whole liter of solution, we would have 2.35 moles, and we want a little bit less than that. The second one here, we know the amount of solution. At least we know the amount of solution in milliliters. And our relationship here, we know the moles in the liters. So we're going to need to convert this to liters first. Might be good to keep handy the fact that there's 1,000 milliliters in a liter. A lot of times people find that particular conversion factor easy to use. just because a lot of times when you're working in lab, you don't have entire liters of solutions that you're working with. A lot of times you're working with milliliters, so you might have to convert this. This will convert it to liters of solution, and now we can use this first conversion factor, and this comes out to be 1.05 moles of HCl, hydrochloric acid.